Section 5.4, Right Angle Trigonometry. Your homework is 7 through 51 every other odd. Alright, so to begin our right angle trigonometry, and make sure you memorize this or get this tattooed somewhere. So it's made up of a ratio. We will create a ratio in relation to a given angle, given that our triangle is a right triangle. So it needs to be a right triangle. Your triangle always has your hypotenuse, and it's the side opposite of your right angle. Now from there, it all depends on our perspective and our angle. So let's say we're looking at our angle T. Then we have an angle that is opposite of it, or a side that's opposite of it, and a side that's touching it, the adjacent side. And you can also argue, well, isn't the hypotenuse adjacent? Technically, yes, but in reality, no. The hypotenuse is its own special side. It's the hypotenuse. Adjacent is the other touching side that's next to it. That's not the hypotenuse. Now, given the triangle shown, find the cosine of theta. Of alpha. So here it's telling us to look at this angle alpha. Now, if we want to find cosine of the angle alpha, it will be made up of cosine is adjacent divided by hypotenuse. The adjacent side, oh, I kind of cut it off. It's 15. And the hypotenuse is 17. So cosine of alpha is 15 divided by 17. And I should have read these out. Sine of t is opposite divided by hypotenuse. Cosine of t is adjacent divided by hypotenuse. And tangent is opposite divided by adjacent. When working with right triangles, the same rules apply regardless of the orientation of the triangle. In fact, we can evaluate the 6 trigonometric functions of either the 2 acute angles in the triangle. It depends on what angle we're referring to. So if we're looking at beta, we have a hypotenuse, a side adjacent to beta, and a side opposite of beta. But what if we're looking at alpha? We have a side opposite of alpha and a side adjacent to alpha. But they all have the same hypotenuse. The hypotenuse is a very special side. So again, it depends on what angle you're looking at, on your perspective, on your view. Using the triangle shown in figure 6, evaluate sine of alpha, cosine alpha, tangent alpha, secant alpha, and cosecant alpha, and cotangent alpha. Okay, well, I failed to list the reciprocals, but just like we have our original 3, we have our reciprocals. And they're the same values, but a flipped fraction. So if sine of t is opposite hypotenuse, then cosecant of t is hypotenuse over your opposite side. If cosine t is adjacent divided by hypotenuse, then secant t is that flipped. So hypotenuse divided by adjacent. And if tangent is opposite over adjacent, then cotangent is adjacent divided by opposite. Okay, let's go on to our current example. So we have the side alpha. Let's label our values. We have our hypotenuse, we have the side opposite of it, and its adjacent side. So if you'd like to, since we're just starting, we can label the values. So sine alpha is opposite over hypotenuse. Cosine alpha is adjacent over hypotenuse. Tangent alpha equals opposite over adjacent. And our reciprocals would be cosecant alpha is hypotenuse over opposite. Secant alpha is hypotenuse over adjacent. And cotangent alpha is adjacent over opposite. Okay, we label our sides. Now it's just a matter of inputting them in. So that opposite side is 4, hypotenuse is 5, adjacent is 3, hypotenuse is 5, and tangent is opposite over adjacent, so 4 over 3. And if we have our original 3, we also have our reciprocals because it's just the flip of the fraction. So we have 5 over 4, 5 over 3, and 3 over 4. This is your right angle trigonometry. This is so important. Make sure you engrave this into your head. Finding trig functions of special angles using side lengths. We have already discussed trig functions as they relate to special angles on the unit circle. Now we can use those relationships to evaluate triangles that contain those special angles. To do so, we find our reference angle and extend a perpendicular line so that it's touching the x-axis. Sides of special triangles. There is an exact proportion that makes up the sides of triangles that have angle measurements. So we have our 30-60-90 triangle and our 45-45-90 triangle. They have these special proportions. So if we have a 90, 30, 60 triangle, we have a special measurement. Now here's a radian measure. I technically like degree measurements a bit better. So we have a 30-60-90 triangle. So if we have this special side, S, the hypotenuse is twice as much that number, so 2 times S, and the side that corresponds to the 60 would be S times square root of 3. So without having to refer to a Pythagorean identity, we can work around and find all 3 sides just by knowing one side. So to erase all my markings to avoid confusion, I will, however, erase those markings so that I can write degrees. So we have a 30, 60, 90 triangle. So to go from 30 degrees, since this is the side that corresponds to 30 degrees, to go from 30 degrees to 60 degrees, you multiply by a square root of 3. To go from 30 degrees to your hypotenuse, you multiply by 2. Now, what if you're given 60 degrees and you want to find 30 degrees? So to go from 60 to 30, you would divide by square root of 3. And to go from your hypotenuse to your 30 degrees, you would divide by 2. And that's what the proportion is trying to tell us. Next, we have a 45-45-90 triangle. So again, I'll erase these markings so I can write my degree measurements because I like that more. 45-45-90 triangle. So this one's a bit easier to remember. Our sides are 1 or whatever value, and to get to our hypotenuse, we multiply by square root of 2. To go from a hypotenuse to a side, we divide by square root of 2. Sorry, excuse me. All right, so here we have a triangle. Find the unknown sides of the triangle. So I have the side that corresponds to my 30 degrees. Now from there, I wish to find my hypotenuse and the side that corresponds to 60 degrees. Well, for that, I use my proportion. So my hypotenuse is twice as much as my side that corresponds to 30 degrees. So C is 2 times 7. C is 14. My A, my side that corresponds to 60 degrees, we need to find that out. Now, according to our triangle, to go from 30 to 60, we need to multiply by a radical 3. So to find A, I take 7 times square root of 3. We get 7 square root of 3. That one wasn't so bad. Example 4. Find the exact value of the trigonometric functions of pi over 3. All right. So we have our unit circle. Ooh. And pi over 3 is the same as, well, let's do that work. If I wanted in degree measurements, it would be 180 over pi. We multiply by 180 over pi, and we get 180 divided by 3, we get 60. So it's the same as 60 degrees. Now I wish to find all 6 trig functions for pi over 3. Now, if you wish to do this as using our proportions, we technically already know this. We know this from 5.2, but we want to introduce, hey, how can you use this using proportions? We know our hypotenuse is always 1 because our unit circle extends from having a radius of 1. So if our hypotenuse is 1, we can also find our 30 degree and our 60 degree. Our 30 degrees is half as much since our hypotenuse is twice as much. So our hypotenuse is, our 30 degree is 2, 1 over 2. And therefore, my 60 degrees I multiply by square root of 3 would be square root of 3 over 2. How did I get this? This proportion. I only know my hypotenuse is 1, which is this guy. It's twice as much as my 30 degrees. So to find 30, I would divide by 2. And to get from 30 to 60, I would multiply a radical 3 to my 30 measurement. Okay, now I can find sine, cosine, and tangent, and therefore our reciprocals. I'll find sine, cosine, tangent, and I'll leave you to find the reciprocals. So our reference angle is this angle here. So we want sine of pi over 3, and yes, you already know these from our last section. But we're using the idea of that special triangle. All right, sine over 3. Sine is, again, opposite over your hypotenuse. Our opposite is square root of 3 over 2 divided by 1. So it's just itself. Cosine is adjacent over hypotenuse. So our adjacent side is 1/2 and our hypotenuse is 1. So we divide by 1, it's just itself. And tangent is adjacent over opposite. opposite over adjacent. So it would be square root of 3 over 2 divided by 1/2, which is just square root of 3. Okay, I invite you to find cosecant of pi over 3, secant of pi over 3, and cotangent of pi over 3. Now, after you work with triangles, and it's kind of hard to do since I try to make these videos too long and you are not meeting with me for 5 units amounts of hours at a time. We we would see if we were to do more problems that between cosine and sine, cotangent, tangent, and secant and cosecant, there are relations and answers that kind of repeat. To that, we have cofunction identities. So if I have cosine of t, it's equal to sine of pi over 2 minus t. And I'll let you do that example. Example 6. To find the height of a tree, a person walks to a point 30 feet from the base of the tree. She measures the angle of 57 degrees between the line of the site to the top of the tree to the ground. And I didn't include the image, so let's be creative and actually draw it. So we have some tree and the ground, and we're looking at the site from the tree to the ground, and it measures 57 degrees. Now we want to find the height of the tree. So we're assuming 90 degrees. This is our unknown. But we know that the person walks to a point of 30 feet from the base of the tree. So we know that this is 30. So how can we find a height using our 90-degree triangle trigonometry? Well, I know an angle. I have an angle. And do we have some trig function where I'm working with the opposite and the adjacent? Yeah, we have two of them. We have tangent and cotangent. We have tangent of theta is equal to opposite over adjacent. So tangent of 50 degrees is equal to our opposite side, which is our unknown, divided by our adjacent side, which is 30. Now we wish to solve for x. Let's multiply both sides by 30. So we're left with 30 times tangent of 50 equals x. Now from there, we use our calculator. So make sure you are in degrees since our measurement is in degrees. And I am not in degrees. Let me make a quick change. So we want tangent of 50 degrees. Press enter times 30. You get 35.75. X is about 35.75. And that is our answer. Well, I hope you enjoyed this section. This was 5.4 right angle trigonometry. Thanks.